This conference will now be recorded.
Okay, great. So this is where we are. So the other day we said what a standard load balancer is, and then we wanted to discuss what a global load balancing solution is. But just before that, let's go ahead do a very quick revision. So I have like four different virtual machines out here, and two belong to a region known as Central US, and the other two, I'm considering these to be my secondary servers. This is my primary region. So the Central US is my primary region, whereas North Europe is a secondary region that I do have. So my intention is that just in case if the Central US server doesn't respond, then that's when the user has to be diverted to, let's say, the North Europe server. This is the mechanism what I want to design out here. But again, if I go with one load balancer, which is just a regional one, so if I use one load balancer out here, a load balancer, as we know, is a regional device. You won't be able to divert the traffic to a different region using a standard regional load balancer out here. So that's where we said there is something known as a global load balancer. And I just asked you all to just go through the documentation for the global load balancer so that we can discuss it today. So what let me do one thing. I have like four servers, but I do not configure any load balancers for this. So let's go ahead do that very quickly so that it will be a good revision for everyone. So I'll say it's just create a load balancer out here. So I will need two load balancers right now. One load balancer in two load balancers. So one load balancer in Central US and the other load balancer in North Europe, so that all the four servers can be accommodated. So this is the architecture that I'm trying to achieve. So I have Central US and I have North Europe. So these are four machines and this is how I want to load balance them out. So right now I'll just go ahead and I'll just create a load balancer here and I'll say this is North or Central US load balancer. And let me give it a Central US location. So I'm changing the location to Central US so that I can load balance the traffic. And this is of the type standard and not a basic. No, I'm not going for a basic load balancing out here. It's a standard load balancer out here. It's a public load balancer because I want to expose myself to the internet. And the tier is a regional one. So it's a regional load balancer. What I'm doing, it's not a global load balancing solution. And as we know, there are a couple of components that are important for us to configure for the load balancer. Can anyone help me? What are all the components here, guys? What all should we configure here? Anyone online, offline? Anyone? Can anyone tell me what are the components basically that we need to configure here when we are creating a load balancer? Anyone? Anything? At least one point?
Load balance public.
Okay. But what are the components that we need to configure for the load balancer out here? Port for the load balancer, name of the load balancer. But let's segregate it in this way. I need a front end IP for the load balancer. So I need a front end IP configuration. Guys, this is really important. Please focus because this is one of the most interviews asked questions that what are all the components that you do when you configure the load balancer and etc. So I have a front end IP configuration. So let's say front end IP config. Going forward, I need a
Back.
load balancing rule. I have a load balancing rule. Finally, I need to configure something known as the backend pools. And along with the backend pool, I need someone to check the backend pool regularly. And this is known as a health probe. So all these is something that I configure for a load balancing service. And this is for a standard regional load balancer. And I say add front end IP configuration. And here this is where I say, okay, fine. I'll just give a name to the central. I'll just give the name to the front-end IP configuration as central US IP. I'll say choose the IP address. So I'll say there is no IP address. So I'll say create a new one. I'll say central IP. Add. So this is something that needs to be created. Going forward, I'll say, okay, fine. I need something known as the backend pool. So this is where I add the backend pool. So this is where I add the servers or associate the servers in the backend pool. I'll say pool central US, and I'll just select the virtual network as demo RG Finally, I'll say it's associated to the NIC card IPv4 addresses. I'll say add, and I have two machines out here, VM1 and VM2, that are belonging to a same virtual network that are in central US. I'll say okay, fine, great, add, and finally I'll say add. So this is how I'm configuring the backend pool. Secondly, or lastly, finally, I'm configuring the inbound rules, wherein I'm saying okay, fine, I need to add a load balancing rule in such a way. I'll say rule central US. I need to add an IP in such a way that whenever anyone visits or anyone hits this particular IP known as central US, I need to divert the traffic to the pool called as central US pool, which consists of two virtual machines. And I need to declare something known as the front end and the back end ports. So it's 80 and 80. And finally, it needs a health probe. So I'll say, fine, please configure a health probe. So I'll say it is central US health probe, HP. I'll say protocol is something like TCP. And I'll say for every 5-second interval, please check the port 80 so that the machines are alive or not. And just in case the machine fails to respond for 2 consecutive times, please mark this machine as unhealthy and removed from the pool. And I'll say okay. Finally, I'll say add. So this is how I'm configuring the inbound rules. And finally, I'll say review and create. So again, we can just confirm what are all we creating out here, like the name of the subscription, the name of the resource group, the name of the load balancer, and etc. And we say, and we finally say, okay, fine, please go ahead and create this out. So this is how you create a load balancer. So let's do that one more time because we have like one more pool of servers that we need to load balance, which is North Europe. So let's also give it a try and see how it works out and all that stuff. So coming back here, this is getting created right now. So the central US load balancer is getting created. This might take somewhere around 1 or 2 minutes to get created. So at that time, let's go ahead and also create the North Europe load balancer. So this load balancer is done. The servers are good now. Servers are in place. Now the load balancer is coming up right now. So we're creating the load balancer in central US region. And going down, we need to also create these basically, I mean, create this particular load balancer out here. I already have these servers. They're running IIS. So I went ahead and installed the IIS. I already have these two servers that are sitting in the backend pool. And finally, I now need a load balancer to manage them. So I'll say, okay, fine. Let me go back to the load balancer and I'll say create a new one. And these both servers, right? They are in Central US, so they are in North Europe region. So let's again clarify that. So let me go back and open up all my virtual machines in the backend. So they're in North Europe. So my load balancer should also be in the same region as the servers are. I cannot have my load balancer in a different region than the servers because again load balancers are regional in nature. So I'll use the same demo RG. I'll say this is North Europe load balancer. The region is North Europe. And finally I say okay fine, this is regional in nature. Then I'll configure the front end IP for the same thing. So it's a front end IP, load balancing rules, backend pools, and also the health probe. So I'll say this is North Europe IP. I'll say create a new one. The North Europe IP load balancer. Add this one out. Finally, in the backend pools, let me go ahead and say add a backend pool. I'll say this is pool North Europe. giving it short form as NU. So this is the only virtual network in the North Europe region. So I'm just selecting this out. I'm saying add, and VM3 and VM4 are the two devices that are there in the backend. I'll say add this one out. In the next inbound rules, the same thing again. Whatever I did for the central US, I'm just doing the same thing for North Europe also. So I'll say in blue North Europe, and I'm saying front end IP. This is the IP address. I'm saying backend pool is pool North Europe. I'll say again 8080. This is the port mapping that I'm doing, and I'll say health probe. So North Europe HP protocol again is TCP. Go and add this out and say add. Finally, I do a review and create. And once this is validation is passed, I'll just go ahead and create this out. Again, I'm creating a load balancer here so that I can manage these two services also. So now I have both of my machines running, VM1 and VM2 running, and I am creating the load balancer right now in North Europe region. So if I now go to the load balancers, I have a central US load balancer that's already created. So I just want to test it to see whether it's working fine or not. So let me go into the front end IP configuration, grab the IP address of this particular load balancer, set my browser, and I'm able to get the IIS server getting loaded. And if I just say / default.html, it says this is server VM1. So there are two servers, VM1 and VM2. Let me open up a new browser and do a couple of refreshes. Now you have a VM2 that is coming into place. So if I just expand my screen, we have a VM2 that is coming into picture. So the request is getting diverted alternatively. So it's VM1, VM2, and etc. Meaning this is how the mechanism is. Load balancers always work in this way. The first request, let's say I have a user who's coming in. The first request is diverted to the VM1. Second request is diverted to VM1. Second request is diverted to VM2. Third request is diverted to VM1. Fourth request is diverted to VM2, and so on and so forth. So it's an alternating fashion. And this kind of a technology or this kind of a methodology is called round robin technique. It's a round robin, ROUND, round robin technique. So that meaning you'll have basically the requests that are coming in will be diverted equally between the available servers. If you have a server 3, the first request will go into server 1, second request will go into server 2, third request will go into server 1 again. Sorry, server 3 again. So it'll be in that particular fashion. So whatever the number of requests, the load balancer will divide them into equal portions and divert the traffic equally out here. So that's the reason if you basically do this refresh again and again. Now at one point in time, my browser will cache all these things out. So I may not get basically the server VM1 again. So let me go ahead. Let me use an incognito window here. VM1. So this is working. In the same way, I also need my North Europe load balancer also to work in the same way. So this is the North Europe load balancer in the same resource group called demo.rg. I'll go into the front end IP configuration, and this is a different IP, 21231 something like this. Now I'll say okay, fine. This is again default.html, so it is the same page basically that I've configured here. So now I have a VM3 coming into place. Let's say this is VM3, and if I refresh this again and again, or let me go into a different browser altogether. VM4. So both the machines are also working here, and I'm satisfied that okay, fine. Both the IPs of both the machines are working. This is how we test it. This is like the initial test. So we make sure that both the requests are actually coming in, so that my machines are highly available right now. Now that was about load balancer. Now I said that as an administrator, I am a user who's not in the front but in the back. I'm coming from the back and I want to, let's say, do an RDP into the machine. Let's say I have two virtual machines out here, VM1 and VM2, in, let's say, this particular region called Central US. So I am an administrator who's working for the organization as an Azure admin. And I now want to, let's say, go into this machine and kind of get some data. I want to go ahead, download some data and etc. But the issue that I have right now is that my organization has placed these machines behind a load balancer. And if you look at this setup, now both the VM1 and VM2 are associated with a load balancer called Central US Load Balancer. So VM1 has a public IP or is inheriting a public IP called 40.78.133.22. And the same public IP here, it's literally the same public IP which is associated to VM2 also. VM2 also has the same public IP, and this is the public IP of the load balancer that is sitting in the front. So if you look at this, this is the load balancer's IP. Whatever the IP that got created and got associated with the load balancer, that's the IP which is being associated with both the virtual machines. Now, just in case, let's say someone asks you, okay, fine, you know what, I have an IP address in Azure, which is called central IP, basically something like this, and and they don't know which machine this is associated to, or they don't know which component it is associated to. So if you go to the overview page of the IP address, here it will clearly say that which service it is associated to. In my case, it's saying it's associated to the Central US -LB load balancer because I've created this out. And when you click on this particular service, it'll take you to that particular service and tell, okay, fine, this is the load balancer, which basically the IP is associated to. This is how we know, or this is how we get to know to which device the IP is associated, how it is associated, and etc. So if I basically use this particular concept, so I go into the VM1, I take the public IP of the VM1, and I'll say MSTSC, which is RDP, nothing but RDP out here, and place it here. So I have a VM1 which is 4078 something like this, and I'll say connect. And no matter how many times I do this, I won't be able to get connected to this particular device or to this particular virtual machine called VM1 because this is the IP of the load balancer that I'm interacting with. It's not the IP of the virtual machine at all. So even VM1 and VM2 will respond in the same way. Now even VM2 is having the same IP right now. It is the same IP. So I won't be able to do an RDP directly into these machines. But I somehow need to unblock, let's say, the administrator. So what can I do right now is that I can now configure, or there's an important concept called NAT rules, network address translation. What exactly these are, like what happens out here is that I can configure a set of rules out here called network address translation rules, or in short NAT rules. And this come under, or this is a concept which comes under the load balancer. So this NAT rules is a concept that comes on or comes under the load balancer, and I can add something known as NAT rules out here so that administrators like myself can do an RDP into the backend virtual machines through the load balancer. So the load balancer now is acting as a proxy, or the load balancer now is acting, let's say, as my communication gateway, so that I can basically use the public IP of the load balancer, go through the load balancer, and do an RDP into virtual machine 1 and virtual machine 2, whichever that I do want out here. So how do I configure them then? So this is the central US load balancer that I do have. And in this, I have something known as inbound NAT rules. This is the concept, or this is the area where I will go ahead and add some rules out here. So I'll say, okay, fine, great. So using this concept, let me go into this out, and I'll say, okay, fine, great. I'll say add this, and it says the rule name. I'll say the first rule is called RDP VM1. I'll say this is the rule so that I can do an RDP into the virtual machine one. I can add anything here, XYZ, ABC, something like this. But I'm just adding a rule to make something like, make a bit of sense so that whenever I come back, I visit this one, I understand what this rule should do. I'll say, okay, this is the front end IP. Now, what is this front end IP, guys? Where is this front end IP? To whom this front end IP is attached to? Anyone? Now, what is this front end IP address? 4078.133.22.
Load balancer IP address.
It's a load balancer IP address. This address is the load balancer's IP address, and I'm saying, okay, fine. You know what? This is the load balancer IP address, and I'm saying, okay, it's a custom. The service is custom here. I'll say whenever someone does an RDP on a port like, no, I'm just mentioning a very random port out here called 4000. I'm saying if someone does an RDP to this particular IP address called 4078.133.22, which is let's say the IP address of the load balancer over a port called 4000, then please go ahead and divert them to VM1. It says, okay, fine, I'll divert them, but can you please give me, let's say, the IP address of that VM1? This is 10.0.0.4. And I'll say, it's saying, okay, fine. The port mapping, it's saying it's default. So I'll say not default, but custom. And I'll say the backend port, on which port number will the RDP work, guys? What is the port number for RDP? Anyone? What should be RDP's port number? Anyone? Any answers here?
3389.
83389. So it is a 3389, which is the port of RDP. So guys, please remember this. This again are very important questions in the interviews that they do ask. So 3389 is RDP, is where RDP works. So it's a port number for RDP. 80 is HTTP. 443 is HTTPS. These are the port numbers that you might want to remember because these are very commonly asked questions out there. And if they go a bit and ask you what is the port number for SQL Server, it is 1433, which is SQL Server. So we'll talk about the SQL Server and etc. But please do remember this out. So now I am saying it is 3389. So this is what I'm doing right now. I'm giving a rule, a name to the rule, and I'm saying if someone hits this front end IP address over a port number called 4000, please divert them to a backend port out here, to a backend port which is 3389 on this particular virtual machine, which is VM1. This is the configuration what I'm giving, and I'm saying, okay, fine, great, add. So I'm adding something known as a network address translation rule. Let's see how that rule really works. So I have added one rule for the virtual machine one. I'll also go ahead and add one more rule for the virtual machine 2 because there are two virtual machines that are there in the backend pool of this particular load balancer, which is central US. So let me do that also. So let's just give it a second so that it'll go ahead and configure. So any questions still here, guys? Like what have we added? How have we added? Is this clear? Does anyone have any questions? Yep.
Now, if you download the VM1 RDP file and we can log in into that.
So, okay, fine. I'll also try doing that. So I will go to connect. So this is VM2. Okay, I'll just try to download the VM RDP file here. No, I'll say okay, fine, great, connect. So no matter what I do here, I still get this error. The reason being there is no particular public IP that is associated with this particular virtual machine. There is no public IP at all. Public IP that was there got overridden when you basically placed a load balancer out here. And this is here telling me that I have a private IP address. Can you please do an RDP out here? But I won't be able to. By default, the rules of the virtual network do not allow me to go ahead and do an RDP out here. Does that answer your question? Someone had that. So that's the reason. That's where I'm coming to this particular rules out here. So this is the first rule. The second one, I'll say okay, fine, add, and I'll add it in a similar fashion. I'll say RDP VM2. This is the second virtual machine. Same IP address. And now if I say it is again 4000, it's now giving me an error telling me that the front end IP port is already allocated and etc. Meaning I've already used this port. So what I did is that I said whenever someone reaches to this port called 4000, please divert them to VM1. So I've already used this port. So one single port can only be allocated to one rule. This is called port exhaustion, meaning I'm exhausting my port out here. So I'll say, okay, fine, it's not 4000. Let us go for 4001 plus 1. I'll say again, target virtual machine is VM2. IP configuration is this one. I'll say custom and I'll say this is 3389. So now I am doing a port mapping out here. So whenever someone hits something known as 4000, please get them diverted to the virtual machine called VM1. If someone reaches out to 4001, then please divert them to something known as VM2. This is what I want to do. So let me come down here again and go into the load balancer service called Central US. I have one rule configured, so let me go there. Now it says this is the rule, which is called RDP1, and this is the front end IP address, and this is the port. So I'll take this out. I'll use this front end IP. I'll do a colon, so two dots out here. So I'm doing something like this. This is how I'm interacting with the machine right now. So it is the IP of the machine or the IP of the load balancer, colon, and the port number that I want to interact with. It's 4000. I'm specifying, I'm telling, okay, fine. By default, RDP works on 3389, but I'm not using 3389 here. I'm saying, okay, fine, over 4000 because that's where basically my network address translation rules are configured. And now I'll say connect. Now it's asking me, can you please give me a user ID and password? So I'll say, okay, fine, great. I'll just go ahead and give the username and password. And it's now telling me that, okay, fine, this is VM1. And I'm getting connected to the virtual machine 1 right now. And I'm using the IP of the load balancer to connect to it. So it says securing the remote connection. Once this is done, I am inside the virtual machine 1 right now. I am now inside the VM1, wherein I can go ahead and do all my configurations. I can download the files and etc. And I have achieved doing an RDP. And here I have used the IP address not of the virtual machine directly, but of the load balancer. And this is only possible because I configured something known as NAT rule out here. Now, if I want to connect to virtual machine 2, I'll use the same IP, but it will be colon 4001 because this is for the second IP. So I'll say, okay, fine, this is for 4001. I'll again say to an RDP. So this is for 4001 and I'll say connect and I'll say this Microsoft 1001. So both the machines have configured the same password. So now it's saying, okay, fine, this is VM2. This is how we end up achieving whatever traffic is there that we need to, or whatever administration work is there. We end up achieving all these tasks using the NAT rule concept out here. And now I am going inside the VM2. So this is same IP address, but I'm using the same IP address again and again so that I can communicate or I can establish communications with both the virtual machines in the backend. Any questions still here, guys? Anyone till here? Any questions still here?
Yeah, just one question. So what about sorry, what about that port numbers? So you took as 4000 and 4001.
Right.
Like in real time, like do you get any inputs about them or like how to choose them?
Any port is fine until 65,000 because there are something known as there are something known as default rules that comes into place. So anything is fine. So I have just taken an example called 4,000. You can take it as a 5,000, 6,000, 7,000, 8,000, whatever it is. Until 60,000, you can take it. So any number is fine. This is just a dummy number that you are giving for your convenience.
So do we do the same in the real time too?
Yes, we do the same in real time too. If we
Okay,
need to do an RDP inside the machine, we establish the RDP over, let's say, any temporary port out there.
got it. Thank you.
Any more questions here, guys? So let me close this RDP sections. So any questions that I can take till here? Now that was about NAT rules. Finally, I had one more thing is that I have 4 machines managed by 2 load balancers, but I need all the 4 machines to help me out so that whenever my primary region goes down, the secondary region in my case is North Europe. So let me take this as North Europe comes out to help me out. This is what I need to do right now. So this is what I need to make sure. So that's the reason I introduce another service called Global Load Balancer. So how do I configure this again? It's again same, go to the load balancer. It's the same configuration literally. But this time when I say create, I'll now call this as, let's say, global. And this is important. It's now asking me what is the region in which you want to configure this something known as a global load balancer. So this is important. I'll have to be very careful in selecting this out. The reason being, if I go into the global load balancer, it says cross region load balancer, which is in preview, which is a feature which is still in preview, which says, okay, fine, you can avoid this one, you can manage your traffic and etc. You can do all these things out. But let me come down and explain this concept known as the home region and participating region. Meaning, you cannot configure a global load balancer in any region apart from this. A global load balancer has to be either in East US to West US, West Europe, something like this. You cannot configure a global load balancer in any region apart from this. And the virtual machine services that you attach has to be coming from one of these regions, which is North Europe, Central US, and etc. It has to come from one of these regions. If it is not, you will not be able to manage those. This is the home and the participating participating regions. This feature called global load balancer is still in preview. That's the reason you have a bit of limitation out here. So I'll just go here and I'll say, since the home region should be one of these, east US to west US, something like this, I'll just take this as east US 2. So I'll say it is east US 2. I'll say this is standard. So the same thing what I did, it's standard, it's public, but it's not regional, it's global. This is what I'll select, or this is where I select. This is called as global. I say global, great. It says, okay, fine, a global class can only be deployed to a home region. Make sure you have a valid region out here. I'll say, yes, I have a valid region. I'll say next. Now it's asking me for the front end configuration of the global load balancer. I'll say global load balancer IP, create an IP. I'll just give a name here called IP global. I'll say add. And in the backend pools, I now don't add the virtual machines. There is no concept of adding the virtual machine here. Rather, in the backend pools, I will add the load balancers. So I created two regional load balancers. In the backend pools, I'll attach the regional load balancers to it. So both the regional load balancers is something that I'll attach. So I'll say add, and it now asks me what are the load balances that you want to add here. I'll say this is pool global. I'll say one is in North Europe, front end IP configuration, something like this. And the one is in Central US, the other is in North Europe. And you can add multiple things out here. There is no limit. I'll say add. Finally, I'll configure the inbound rules. I'll say this is rule global. Rule global. The front end IP is the front end IP of the global load balancer. Backend pool is the pool global. I'll say whenever someone hits 80, please go them and divert them to, let's say, something known as 80 backend. I'll say add. There is no concept of health probe here. Global load balancer doesn't have an health probe. It uses the health probe of the regional load balancers in order to check how the machines are working in the backend. Then say review and create. So I have an IP address that is associated with the global load balancer. So I have an IP here, which is IP Central US. I have an IP address here, which is IP North Europe. And I will now create an IP here also, which is IP global. Now these IP addresses, right, IP Central US and IP North Europe, are for my backend administrators so that they can do an RDP using the NAT rule concept. This is the IP address that I will now give to the entire world, so that whenever someone comes from, let's say, this particular, any region, hits the IP global, this load balancer manages both the load balancers and diverts the traffic accordingly. Can divert the traffic accordingly. So it's completed the deployment. So let me go into the global load balancer. So this is how my global load balancer looks like, and this is the IP address of the global load balancer. So let's check this out. So this is the IP that I'll be exposing to the entire world. So I'll check this out. I'll just go here and I'll say, okay, fine, great. As a default dot HTML. It says this is server VM3. If I refresh this again, it'll still say that because my browser has cached this values and etc. So I'll just go into an incognito window. It is VM4. Now which region does VM3 and VM4 belong to, guys? North Europe. It's only giving me the traffic to North Europe because I am geographically close to North Europe. My location, I am in India. I am closer to North Europe, like country like Germany and etc., than US. Right? So I'm physically very close to them. So that's the reason these servers are now called low latency servers for me because they are responding in a very quick, in a very quick time span here. So that's the reason the load balancer is able to identify my IP and then divert me to these servers so that it can avoid, let's say, or it can give, let's say, a quick response out here. If you are a person who's coming from central US and trying to hit this server, then either VM1 or VM2 will respond. Now, if I stop one of the servers, so if I just go here, so let's say that my VM3 has gone down. So I'll just stop this VM3. So I'm now simulating a failover situation wherein wherein I'm just stopping one of the virtual machines out here, which is called VM3. Now, if I refresh my page, VM4 is coming up. So this is my primary region, or this is the region where I'm going to. If I go ahead and stop the VM4 also, now what should happen? Or VM2. So any one of the virtual machines, VM1 or VM2 should now respond for me. So using the same IP, I'm not changing the IP. Since it's cached my browser, it will take some time to respond. So let me do this. Let me use an incognito window. Now this will take time because this is the time what the virtual machine, or this is the time what the global load balancer is trying to understand the virtual machines are down. So it will take some time and it will basically take me out to something like virtual machine 1 or virtual machine 2. So sometimes it might take, since the feature is in preview, so this is a preview feature, since the feature is in preview, it might sometimes take like about 4 or 5 minutes of time to understand this and then divert the traffic accordingly. So this is how you do a global load balancer right now. I think it's a bit down right now. So let's try this out. This might take some time. This might give you some error like this because it's still trying to take you using your browser cache. It still might, it's still trying to take you to, let's say, VM3 or VM4. So that's the reason it's a bit slow right now. But when I clear my browser cache and come back again, it should take me either to, let's say, VM1 or VM2. But again, it might take some time, like about 4 or 5 minutes. It might take some time. The feature is still in preview. Now, once it is, let's say, available for everyone, that's when the feature would be, let's say, not too fast and etc. Any questions still here, guys? Anyone? Any questions still here? Anyone? Anything till you?
Hi, Kiran. Hello.
Yeah. Hello.
Uh, we are creating four virtual machines. Doesn't that increase my cost?
Yes, it will definitely increase my cost. So
I
for one
mean,
virtual
in
machine,
real time, yeah.
yeah, for one virtual machine, I'm paying around 3 rupees per an hour. So for four virtual machines, it's 3 into 4. 12 rupees basically that I'm paying for all these virtual machines together.
In real time, we do this like creating 4 to 6 virtual machines and creating global load balancers.
In real time, you don't have 3 to 4 machines, you will have hundreds of machines, not just three to four.
Okay, okay,
But let's say if I'm a company like Facebook.com or something like that, I don't really care about the cost. I'm really caring about the availability right now. So I need to make sure that the virtual machines are available.
okay,
Just a sec.
okay. Thank you.
Uh, yeah, just a sec. So in reality, I have like about hundreds of servers that are running in the backend, which will help me out in order to fetch this request and etc. So it is cost versus availability. So this is how I design something known as high availability out here.
Okay, thank you.
Any more questions that I can take here, guys? And finally, when you're done, please go ahead and make sure to clean up all these resources because this will cost you a lot. So I have created just one particular resource group. So this is a best practice because I want to delete all of them at the same time. So in one particular resource group, I have so many resources out here that got created. So I have so many tons of resources that got created. So after doing all this experimentation, you can just go ahead delete your entire resource group. So that all the resources are deleted at one go. Okay. Any more questions for today, guys? Anything for today? Anyone? Anything for today? Anyone? Does anyone want to ask anything for today? Okay, if no further questions, then we are good to close the session for today, guys. Thank you, and we'll meet tomorrow. Thank you, guys.